right, so here we'll be discussing how to evaluate trigonometric function of any angle. But before we do that, we need to talk about reference angle. So if you have an angle theta, which is in standard form, then the reference angle, which is theta prime, is the smallest positive angle formed by the terminal side of angle theta and the x-axis. So for example, if you are in the first quadrant, this is your theta, the green theta is in standard form. So the smallest angle between your x-axis and the terminal side is still the same. So that is why we said theta prime is equals to theta. But if you go to the second quadrant, this your green, the green theta here is angle in standard position. Why is it in standard position? Because the initial side is the positive x-axis, while the vertex is what? Is also 0, 0, the origin. So, but the smallest angle between the terminal and the x-axis is what we call what? Theta prime, right? So that is our reference angle. So our reference angle is not the green one, but the red one. But you can see that if you add this one, you see that the theta prime plus theta will give us what? 180, right? So it means you can make theta prime the subject. So theta prime is going to be 180 minus theta, which you can write as pi minus theta, right? So in the third quadrant, if you have your terminal in the third quadrant, you can see that the green one, starting from the positive x-axis up to this point, is our standard, the angle in standard notation. But you can also form another angle between the negative x-axis and the terminal, which is the smallest, because it's this. Remember, the reference angle is the positive, smallest positive, look at it, smallest positive angle formed by what? The terminal side of angle theta and the x-axis. So this is the smallest one here, which is theta prime. Theta prime. And you can see that here, if you look carefully in this diagram, you will see that what? That theta prime plus what? Plus 180 is going to give you the whole theta. It will give you the green theta, right? And then from here, you can see that we can make theta prime the subject of the formula. So have theta minus 180. Similarly here in the fourth quadrant, also this is the green one, which is in standard position. And this is the reference angle. So you see here, you can easily see that theta prime plus theta will give us 360, right? Then we can make theta prime the subject. All right, so there's also a note here, is that if the theta is negative or greater than 360, the first thing we should do is we should find the coterminal angle before we find the reference angle. All right, so let's just answer these few questions. So for example, now this theta is 5 pi over 3. So you just need to know which quadrants it belongs to. So now one way to check this is simply you use this one. This is 0, this is pi over 2, this is pi, and this is 3 pi by 2. So if you look at this now, this number is 5 over 3. So all you need to do is definitely 5 over 3 is greater than what? Than pi. So you cannot be in the first, you cannot be in the second. So it's either we are in the third or in the fourth quadrant. But now you need to compare these coefficients. You need to compare 5 over 3 and what? 3 over 2. So you can see that what? 5 over 3 is greater than 3 over 2, because if you multiply this times this will give us 10, this time this will give us 9, right? So this fraction is bigger. So it means that since it is bigger than 3, so it's not here, but it's going to be in the fourth quadrant, right? Yes, so if it's in the fourth quadrant, So we see our theta belongs to what? Let me put it here, quadrant 4. So therefore, the reference theta prime, remember, is going to be 2 pi minus theta. This is how we find reference angle in quadrant 4. So this is simply 2 pi minus what? 5 pi over 3. And this should give us just pi over 3. Right? So for the B, the first thing we need to do here is we need to find first we can change it. Look at it. If theta is negative or greater than 360, the first thing we do is we find the coterminal. So since it's negative first, I will find the coterminal. Coterminal is going to be theta. Now, which is what is going to be theta. Since the theta is negative, so we have, and then we add what? K times 360 degree, right? But it's okay. If you take K to be 1, it's fine. So this will be minus 210 plus what? Plus 360, right? And this will give us what? This will give us, I think, 150. Yeah, 150 degrees. So this would give us 150 degrees. Okay. Now, we'll now find a reference. Since this one, and don't forget, this is in which quadrant? This is in quadrant 2. So theta prime is going to be 180 minus what? Minus 150, which is equals to 30 degrees. So this is our reference angle. Right. So similarly here, this is a big number, so we'll find the coterminal first. Coterminal is going to be 1924. But since this is very big, we can subtract what? We can subtract K 360 degrees, right? And now what can we take as K? We can take K to be what? We can take K to be, we can try as many. Now, if you take K to be 2, it's still going to be what? It's still going to be greater than 360. So we can keep increasing the K until we have something that is less than what? Less than 360. So for example, if you take K to be, I think we can take K to be what? Let's take K to be 5. We'll have 1924 degree minus 5 times 360. So you have to try these numbers. So this is going to be 1,800, right? So 1,800. Now you need to check, what do you have? What you have left, is it going to be greater? If it is greater than 360, then we need to what? We need to subtract again, right? So, but I think this is fine. So your coterminal, in this case, is what? 124 degree. And this is in which quadrant? This belongs to quadrant 2 still yet. So our reference theta, which is theta prime, is going to be what? It's going to be 180 minus 24, right? So you have 180 degree minus 124, right? Now, this is going to be our what? Our reference, because we are in the second quadrant, right? And this will just be 56 degree. So this is our reference. Okay. Now for D, we're dealing with pi. So what can we do? Here also, we can find the coterminal first. coterminal will be what? Minus 2, 23 over 7. Now we have to add k to pi, right? So what can we choose as k? If we choose k to be, I think we can choose k to be 4, right? Or 2. If we choose k to be 2, you have this one, right? Plus what? Plus 4 pi. This is, we're taking k to be 2 until we get the positive, which is less than 360, right? Now, so this will be what? This will be minus 23 pi over 7. And this is going to be what? It's going to be 28, right? Yep. This is going to be 28 pi, I think, over 7, right? Yeah, because we have 7 times 4. Yeah, 7 times 4 should be 28. So now, this coterminal is nothing but what? This will just give us 5 pi over 7. All right. Now, 5 pi over 7 is in which quadrant now? That is what we need to look at. So if you look at 5 pi, you can always convert it to degree if that is easier for you to do. But this is what we can do here. We know this is 0, this is pi over 2, right? And this is what? This is pi. This is 3 pi over what? Over 2. So the question is, where is this number here? 5. This number here, which is, we're going to compare it with what? We're going to compare it with 1 over 2, right? Because here, what is the coefficient here? This is 1 over 2. And now you can see if you compare 5 over 7 and 1 over 2, what do you get? You get that 5 over 7 is greater than what? Is greater than half. So it means that this number cannot be in the first quadrant, right? So it's going to be in the what? In the second quadrant. Yes. But now you might ask yourself, is it going to be, could it be in the first or it could be in the second? Now, if you look at this number, can it be in the third quadrant? Because this is 1. Now, since this is 1, and this number we know is not up to 1, right? So it means you cannot cross 180. So it cannot be in the third quadrant. So it has to be in the what? In the second quadrant. Is that okay? So this is how to check. Or you can easily convert it to what? Convert it to degree. You can multiply by what? 180 over what? Over pi. And then you can try to get your estimate value in terms of what? In terms of degree, right? So this will go with this. Then you can just try to, you can try to divide or just have an approximate value. This will definitely be in the second quadrant because this and this will give you about 900, right? And then you are dividing by 7. So you're going to be around 100 and something, maybe 120 something. Okay, so you're going to be in the second quadrant. All right, so since you are in the second quadrant, this is in what? In quadrant what? Quadrant number 2. So this prime is still going to be what? In quadrant number 2, we use pi, right? Minus theta, but what is our theta now? We're going to use this one, right? So it means that theta prime is just going to be 7 pi minus 5 pi, right? All over 7, which is just 2 pi over 7. So this is the reference angle. Okay. All right. Then for this E and F, you see that these are all in radian. But here, since there is no pi, we know it's radian. Now, we have to know the quadrants. Here, remember, we use this, this is pi over 2. Excuse me. So here, we want to use the approximate values of pi, right? All right, so here, pi over 2 is approximately 1.57. Here is approximately, which is the position of pi. So pi here is approximately 3.14. And here also we have pi. This is 3 pi over 2, which is approximately, that's about 4 point something, right? So this would be around 4.7. Yes, around 4.7. And here we have 2 pi, which is approximately around 6.28. Now, if you look at this 10, so it means that 10 itself is greater than 2 pi, because 2 pi is what? Is around 6.28. So it means, first of all, we need to find the coterminal. So the coterminal is going to be 10 minus k2 pi, right? Is how to find coterminal. Then we can see what should be k. If we take k to be 1, is it enough? If we take k to be 1, we will have the coterminal is 10 minus 2 pi. Now, what is 10 minus 2 pi? 10 minus 2 pi, this is approximately equals to what? Because this is 10 minus 2 pi is what? 6.28, right? 6.28 is because this is, we're using approximate values of pi, right? So this is 6.28. So now if you subtract 6.28 from 10, we will have about 3 point, we'll have 3.72, right? Yeah, so about 3 point something. So what does this mean? This means that this number, this is the coterminal. So this coterminal is less than what? It's less than 2 pi. So it's fine. So it means that we have this, but now if you look at this number, which we have, is in which quadrant? 3.72 approximately, definitely is not in what? It's not in the fourth quadrant. It's going to be in the what? In the third quadrant, right? It's going to be in the third quadrant. Okay, yeah. So this is in the third quadrant. So this is in quadrant number 3, right? And since it's in quadrant number 3, how do you find reference angle in quadrant number 3? It's going to be the theta itself, right? Minus what? Minus pi. Okay. So this means, what is the theta? Which theta are we using? We are not using this 10 again. We're using the coterminal value, which is this one, which is 10 minus 2 pi minus pi. So our final answer is just going to be 10 minus what? So this is 10 minus 3 pi. All right. So F is this. For F, what we can do is also we test. So you can see that 16 is greater than what? 16 is also greater than 2 pi. So, because we are still using this one, we're still using 2 pi. It's approximately 6.28. Pi over 2 is approximately 1.57. And pi is approximately what? 3.142. And 3 pi over 2 is approximately 4.7 something. So here, 16, definitely 16 is bigger than what? Than 6.2. So we will use the coterminal just as we did before. So coterminal is what? Is going to be 16 minus k2 pi, right? Minus k2 pi. So now we need to think of which k is suitable. So here, if you try to use k to be 1, then it's not going to work because you have 16 minus 6.28. It's still bigger. It's still bigger than 6.28. So you have to increase the k. So let's try k to be equals to 4. If k is equals to 4, you'll have 16 minus what? You have 16 minus 8 pi. So 16 minus 8 pi, this is going to be 16 minus 8 pi is just going to be what? It's going to be 8 times 3.14 something. So you see this is going to be a negative number. So it means you can't take k to be 4. That's too big because we still want to have a positive number. All right, so we have to reduce the k. So let's take k to be what? K to be 2. If k is 2, this will become 4 pi. Yeah, this will make sense because this will be 16 minus 4 pi is just what's 4 pi is going to be 12. Let's say 12 point, let's say 12. Yeah, it's going to be, let's say like 12.5 something, right? Yeah, it's just going to be about 12.56. Now, if you take the difference between this and this, it's going to be 4 point something, right? So, which makes sense. Now, you need to ask yourself, where will it be? Because you have, remember, you have 4 times this. So we're taking k to be 2, right? So if you do 4 times 6 points, yeah. So you have 4 times 6 points, not 6 point again, sorry. Because we have 4 pi here. When k is 2, we have 4 pi. So you just have 4 times 3.142, which is about 12.568, yes? Now, if you subtract this from 16, or you take L16, this is approximately, let's say around 3 point something, let's say 3.4 something like this. So you see that this number is in which quadrant now? 3.43 is going to be in quadrant number what? It's going to be in quadrant number 3, right? So what it simply means is that what? 16 minus 4 pi is in what? Is in quadrant number 3 again. So if you want to find the reference angle, it's just going to be the angle itself, remember, which is going to be 16 minus 4, or let me write theta. But instead of using theta now, we can just use the coterminal, yeah, not the theta itself. So it's going to be the coterminal theta we found, then minus pi. So this is 16 minus 4 pi minus pi. And this is going to be 16 minus what? 5 pi. Okay. All right. So this is how we find reference angle. So now we know how to find reference angle. Then the next thing is the reference angle theorem. So this theorem is very important because we use it to find the trigonometric function of angles that are not acute. So how do we use this reference angle theorem? The first thing is that if you want to find trigonometric function of angles that are not acute, it means they are not for angles greater than 90. So you can first of all locate the quadrants of the angle, which is theta. Then you are to determine whether the trigonometric function, because if we know the quadrant, we will know whether the trigonometric function is positive or negative. So that's what we mean by determining the sign. Either it's positive or negative of the trig function. So it could be any of the 6 trig functions we discussed: the sine, the cosine, tan, sec, and cotan, right? And also cosec. So number 3 is that you find the reference angle, because if we know the quadrant, we can find the reference angle. Then we use this relationship. So the trig of that theta you're looking for is just going to be the same as what? The trig of what? Of your reference angle. Now, so it could be either plus or minus, depending on what is the sign of the function in the quadrant. Okay, so I will illustrate with these examples. So let's see example 8. What is it saying here? I think I should have some space here. All right, so let's solve this one. So here, we're going to use the reference angle theorem. Now, to answer this one, you start with what? With this angle. This angle here is already what? Is already bigger than 360. So the first thing we have to do is to what? Is to find the coterminal, right? To find the coterminal. And what will be the coterminal here? So let's look for the coterminal first. The coterminal of this will be, you have 60 minus what? Remember, it's going to be K360. And you can actually take K to be 1 in this case, right? So we can take K to be 1. So this, our coterminal angle is this one. If you take K to be 1, we will just have what? We will just have 570. 570, we'll subtract what? 360, and we will have 210, yes? So this is when we take K to be 1. So the coterminal will just be 570 minus 360, which is 210 degree. So it means we're going to use the coterminal. So let me do separately. So if we're looking for tan 70, this is simply the same as what? Tan 2, 1, 3. So now this is the coterminal, right? Okay. All right. Okay. Now what next do? We know this quadrant. Which quadrant is this? 2, 1, 10. 2, 1, 10 should be in quadrant number 3, because this is greater than what? It's greater than 180. Now, since it's in quadrant number 3, and we know that in quadrant number 3, tan is what? Tan is positive. So it means this is just going to be the same thing as tan of what? Theta prime, which is the reference. So now you have to find the reference angle of what? 210. So the reference angle of 210, remember we are in the third quadrant. And how do you find reference angle in the third quadrant? It's going to be the theta minus 180, right? So which will be 210 minus what? Minus 180 degree. Okay. So here, what have we used here? We have used the fact that we are in D. So now here I'm using reference angle. Okay. Because this is in what? This is in quadrant 3. 210 is in quadrant 3. And then this will just give us tan of what? 30 degree. And what is tan 30 degree? Tan 30 degree is just 1 over what? 1 over root 3, right? Okay. Oh. Now, let's leave that apart. Now, let's go for the second term. The second term is cosec. Cosec what? Cosec minus 120 degree. So the first thing you do is you try to find the coterminal and make this to become positive number, right? So to do that, you will have cosec of what? You just need to find the coterminal. The coterminal is here you have to add, since you want to make it positive, you can add k times what? 360, right? And here, what is the k? Which k can we use? I think we can use k to be 3. So if you take k to be 3, you will have cosec of minus plus 3 will be 1080, right? 180. And now if you look at this one, what do we get? We have 1020, then with a minus, right? Then if you add 1080, you have just 60 degrees. So this is going to be cosec of what? 60 degrees, right? Now 60 degrees, but 60 degree is in which quadrant? So up till this moment, what have we used? We have used only coterminal here. So if we use just coterminal, so this is the coterminal. 60 degree is the coterminal. Then we'll look at 60 degrees. 60 degree belongs to which quadrant? It's in quadrant 1, right? So if it's in quadrant 1, it means it's going to be the same as the reference. So it's still going to be cosec 60, because this 60 is still the reference. Because when you are in the first quadrant, remember, these are the same. So now you need to find what is cosec of what? Cosec of 60. Now, cosec 60 is going to be the reciprocal of what? The reciprocal of sine 60. So this is just going to be 2 over what? 2 over root 3, right? Okay. So finally, we can say our answer now, tan 570 degree plus cosec minus is just going to be 1 over root 3 plus what? 2 over root of 3. And this is nothing but 3 over root of 3. If we multiply by root 3 by root 3, what do we get? We get 3 root 3 divided by 3, which is just root of 3. Okay. So what is the procedure? First of all, get the coterminal, then get the reference angle. But here also you can see in the what? In the first quadrant, cosec is also positive. So that is why from here to here, we still maintain it to be positive. All right, so let's see another one. Now, this one is talking about sec. So let's start with sec first. So we have sec of minus 23 pi over 6. So one thing we can do here is we can take the coterminal until it becomes positive, right? So this is the same thing as sec of what? Minus 23 pi over 6. And it's going to be plus k2 pi in this case. Now, what can we take as k? I think we can take k to be 2. If you take k to be 2, you will have sec of what? Minus 2 pi over 6 plus 4 pi, right? And if you look carefully, this is going to be sec of what? Minus 23 pi plus 24 pi over what? Over 6. So it's just going to be sec of what? It's just going to be sec of pi over 6. Now, all of this from here to here, what we're trying to find is the coterminal, right? Angle. Now that you know, this is pi over 6, but we know pi over 6 is in which quadrant? Is in quadrant 1. Since it's in quadrant 1, it means it's going to be the same thing as the reference angle, right? Okay, it's going to be the same thing as the reference angle. So it's just going to be sec. And in the first quadrant, sec is also positive. So this is just going to be, you just look for sec pi over 6. And what is sec pi over 6? Remember, sec is related to cosine. So cosine 30 is what? Cosine 30 is root 3 over 2, right? So this is going to be 2 over root of 3, right? So now let's go with what? Cotan now. So here we have cotan of 16 pi over 3. The same thing. If you look at 16 over 3 is greater than 2 pi. So you need coterminal. So the first thing you do is this will be 16 pi over 3. You have to remove 2k pi, k2 pi, depending on what should be k, right? So what can we take to be k? If you take k to be 2, you have 16 pi minus 14. I think k equals to 2 will work also. So you have cotan 16 over 3 minus what? Minus 4 pi. And this will be cotan of 16 pi over what? I think 12 pi over 3, right? And this is going to be cotan of what? 16 pi minus 12 pi is going to be 4 pi. 4 pi over 3, okay? Now, all of this is coterminal, but now look at 4 pi over 3. 4 pi over 3, we need to ask ourselves, which quadrant is 4 pi over 3? So 4 pi over 3 is going to be in the third quadrant because 4 over 3 is greater than 1. So this is going to be in the third quadrant. So you know that 4 pi over 3 is in quadrant 3. Now, and also in the third quadrant, we know cotan is what? Cotan is positive, so no problem. So it means we don't need to bring any negative out. So this is what? So this is simply cotan of what? Now you have to find the reference angle. In the third quadrant, remember the reference angle will be the theta itself minus what? Minus pi. Because it will be theta minus 180. And now this will be cotan of what? Just pi over 3, right? Yes. And what is cotan? Pi over 3. Cotan pi over 3 is the same thing as cotan of 60. And cotan of 60 is going to be 1 over root of what? Root of 3, because we know that tan 60 is what? Root 3. So this is what we have here, right? Now, this means that this you will just be what? 2 over root 3 multiplied by 1 over root 3. And your answer is going to be just 2 over 3. Okay. Mm. So let's take this last one. And, so this one, find the exact value of minus tan 780 degree sine 570 minus sec this. So here, all these, we can do it one by one. So let's start with minus tan 8, this one. So this one is going to be minus tan. We just find the coterminal. So I'll go straight. The coterminal of this, you have to remove 7 what? You have to remove 760, right? Yeah, 760 or 720. You have to remove 720. And if you remove 720 from this is just going to be 60 degrees, right? Now, what have I checked here? From here to here, I just found the coterminal. Coterminal, okay? Now, since we are in 60 degree, but now 60 degree is what? 60 degree, your theta is in quadrant 1. Now, since it's in quadrant 1, it's okay. It's just going to be minus tan 60. This is easy to find. So this is minus tan 60 is root 3. So you have minus root 3 here. This is for the first term. Now, for the second term, which is sine 570, right? This also we can look for coterminal. And here it's just going to be sine of what? 570. You can remove, we can remove 360, and I think we will just be fine. If you remove 360, you should get something that is between less than 360, right? So this is just the coterminal. All right. Now, please listen here. If you look at this now, this is 210, but 210 is in quadrant 3. So since it's in quadrant 3, and sine is negative in quadrant 3, this 210 is in quadrant number 3. And sine is negative in that quadrant. So here will become minus sine. Then the reference angle now will be 210 minus what? 180. So here we are looking for the reference angle. So you have to, this is very important, this minus here, you see it's going to be minus, simply because sine is what? Is negative in the third quadrant. Okay, so this will be what? This is minus sine of what? 210 minus 180 is just going to be 30 degree. And now this is minus sine 30 is half, right? But we have a minus. So this is what we have here. All right. Then let's look for the third term. So where is the third term? The third term is this one, which is, let's forget about the minus first. Let's take sec. Sec minus 585 degree. Now, what is this one? This also, we can find the coterminal, or we can use the fact that what? Sec is also what? Is even. Cosine is even, sec is even. So this actually, if you like, you can just say this is sec of what? 585. You just discard the minus. But this you can only do it for what? Let me say sec and cosine are what? Even function. are even functions. Okay, so you can use this always. So you can forget about the minus. Now you find the what? The coterminal. You find the coterminal, this will become what? Sec of what? Here you can remove 360, right? If you remove 360 here, we will get what? So we'll remove 360. Just to get what? Just to get our quadrant. We want to know where this quadrant will belong, yeah? So we have 225. Yes. Now that we have 225, then we know that 225 is in which quadrant? 225 is going to be in quadrant number 3 also. It's going to be in quadrant number 3. Now, since it's in quadrant number 3, and in quadrant number 3, we know that sec is what? Is negative. So this is going to be negative sec of what? In quadrant 3, the reference angle is going to be 225 minus what? Minus 180 degree. So now this is reference angle, reference. Okay, just as we mentioned the other time, this is very important here. This negative has to come out. If we don't have this negative, then it will be wrong, right? So now we can finish it up. So this is just going to be minus, so let's change this. Okay, so this is going to be minus sec of what? Of 45, right? Okay, but what is sec 45? Sec 45 is the what? The reciprocal of what? Of cosine 45. So this is just minus what? You can say root 2 over 2, right? Okay, or 1 over root 2. All right. So now I think we can put everything together now. So let me write it here again. Therefore, remember, what are we looking for? We're looking for minus tan 780 degree multiplying by sine 570 degree, then minus sec of minus this, right? So what would this be here? This already, we have it here, which is this one. So this is just going to be, because we took everything with the minus, right? So we have this. So this is minus root 3 multiplying by sine of this, which is minus 1 over 2. Then minus, right, is coming. And here, remember here, we took only sec, and it gave us minus. So sec of this is this. So it's going to be minus what? Root 2 over 2. This is, so there's another minus here, because there is a minus here, right? Now, this and this will cancel, so we have just root 3 over 2, and then plus, this will become root 2, root 2, is it root 2 over 2? 2 over 2, right? And this is nothing but, because here we have half, So this half will multiply. So this is root 3 plus root 2 over 2. Right, so I will see. Yeah, I think there is something wrong here. If you look at this is sec, so I think this is wrong. Here it's minus, right? But sec 45 is just what? It's just root 2, right? Yes, because we know that what? We know that cosine 45 is what? Is 1 over root 2. Yeah, so this is just minus root 2 here. So it means that we will have something different here. This is just going to be minus, and this is minus root 2 here. So this is going to be minus root 3 minus 1 is this, but this minus becomes plus. So you have plus root 2. And now you can make it the same denominator. So this becomes root 3 plus 2 root 2 all over 2. So the answer is actually A. It's correct. Okay, so I think this is okay for this video. We will take fundamental identities in the next video. Thank you for watching.